Kita dah belajar cara mengira formula empirik bagi sebatian. Hari ini kita nak tengok demonstrasi dalam makmal penentuan formula empirik bagi dua sebatian yang berbeza. Kita ada demonstrasi yang pertama, iaitu logam yang kurang reaktif dengan menggunakan kaedah penurunan, manakala logam reaktif bagi demonstrasi yang kedua menggunakan kaedah pengoksidaan magnesium. Jadi cikgu nak kamu semua beri perhatian kepada dua jenis demonstrasi eksperimen penentuan formula empirik ini dan cuba fahamkan apa sebenarnya yang sedang berlaku, ya. Jom kita tengok.
Enables us to find the formula of copper oxide by reducing it in a stream of hydrogen. The hydrogen removes the oxygen and forms water, which will be steam at the temperature of the experiment. This is the apparatus we use, a Pyrex reduction tube, which is essentially a boiling tube with a small hole in the end to allow excess hydrogen to escape. We first need to weigh the empty reduction tube. The balance used must read to at least 2 decimal places. We now place about 3 grams of copper oxide, which is really a couple of spatulafuls of the powder, into the reduction tube. Try to place this in the center of the tube. Having put the copper oxide into the tube, we reweigh it. The copper oxide should be dry. Old stock may need to be dried in an oven or desiccator. Now place the hydrogen delivery tube in the end of the reduction tube. The next step is to light the hydrogen, but it's important to wait for about a minute to make sure all the hydrogen has flushed out any air from the reduction tube, otherwise you could get an explosive mixture in there. For the lighting process, we have safety screens to protect the demonstrator and the audience. Light the hydrogen and adjust the flame until it's about 2 centimeters or so. Explosion risk, so we can dispense with the safety screens. Copper oxide, using a roaring Bunsen flame and using the hottest part of the flame, which is just beyond the blue cone. At this point, a number of interesting observations can be made, and these will probably need to be pointed out to the audience. Droplets of water will condense on the cooler part of the reduction tube near the hole. These will evaporate as the tube gets hotter. The height of the flame will drop as some of the hydrogen is used up, reacting with the oxygen in the copper oxide. The flame may develop a green coloration caused by copper atoms vaporized into the flame. Use the Bunsen burner to chase the glow along the length of the oxide until all the black copper oxide has been changed to pinkish copper. This will take up to a minute. When no trace of black remains, continue to heat for at least a further minute to ensure that all the oxide on the inside of the heap has reacted. If in any doubt, continue heating for longer. Make sure original height, you can stop heating. It's now important to leave the apparatus exactly as it is with the hydrogen flowing. This is to prevent air from diffusing back into the reduction tube and converting some of the hot copper back to the oxide. Continue until the tube is cool enough to touch comfortably. We now blow out the flame Remove the hydrogen delivery tube and turn off the cylinder. And reweigh the tube, which now contains copper.
For this experiment, so this is called the crucible. And of course this is the cover that goes with that. Be careful with the crucible. We'll take the mass of that. So the mass of our crucible and cover empty is 34.30 grams. So on our data table we have a category or a spot for the mass of the dry crucible and lid, which would have as 34.30 grams. And this is pretty easily done. And then we'll add that to our crucible, and then we'll get the mass of our crucible, cover, plus our lid. Okay, so let's move this up. You can see me do this for what it's worth. Boom, and boom. So let's see what we end up there with 34.47 grams. So we'll record that. Place the crucible on our clay triangle, and we'll then go ahead and light this. Okay. And the best height would be, I'm going to lower this just a little bit and make sure you do this while it's cool, not hot. The height of your flame should be so the tip of that inner blue cone is at the base of what you're heating. So that is nice and hot, and we'll get that to react with the air in the room here, hopefully before long. You see that the magnesium is burning in the air. We're going to put the lid on, and you should do that as soon as you see that happening in the lab. So we'll do that quickly. Just put the lid right over top. We'll leave it open just a little crack to let some air get in there. We'll use our crucible tongs, and we'll take the lid off just to let some more air in there. And let's take a look and see what we have. You can see it's, whoops, still reacting a bit. We'll allow that to continue. In the interest of time, let me go through what we'll be doing here in just a moment. After this is heated, what we will do is we'll allow it to cool for about 3 minutes. We can remove the lid at this time. Once again, please use your crucible tongs. This is very, very hot at this time. You will burn yourself quite badly if you're not careful. Let's take a look and see what we have down there. Okay, you can see the bottom of the crucible is still glowing red. As well allow it to cool. And we will find the mass of the crucible lid in our product finally. We can do that after the reaction's over and it's cool. We'll never weigh anything hot.